right, welcome to our conditional probability lesson. Okay, so for this lesson, we started by playing a game of Trashkaball. And what we did is randomly made two teams, made a team that we called left side team, and then a team that we called right side team. And essentially, we had the left side team shoot, and we recorded made shots and missed shots. And then we had the right side team shoot, and we had them record made shots and missed shots. So I'm just going to put in some data here so we can have some numbers to work with. So for one of my classes last year, the left team made 6 shots and they missed 9 shots. So they took a total of 15 shots. The right team made 7 shots, missed 11 shots, and made a total of 18 shots. And so totally we had 13 made shots and we had 20 missed shots. So our total number of shots was 33. Okay, so this is called a two-way table, two-way frequency table, and we're going to use it to answer some questions about probability. So the first question is, what is the probability that the shot was made? So notice this notation, the P means probability, so we say what's the probability of a made shot? So we will look at how many shots were made out of the total number of shots. So we had 13 made shots out of 33 total shots. And that's as much as we can reduce it, so I'll leave the fraction just like that. Second question, what's the probability a shot was taken by someone on the left side? Okay, so there were 15 total shots taken by the left side out of 33 total shots taken. So 15 out of 33. C says, what's the probability a shot was made and the shooter was on the left side? Okay, all right, so when we see the and, that means it needs to fulfill both conditions. So I'm going to look at the made shot column and the left side team. So where do those two spots, those two circles overlap? Well, they overlap right here. So 6 is where I see, okay, 6 shots were made by the left side team. So 6 out of 33 total shots. All right, so let's try another and one. What's the probability a shot was missed and the shooter was on the right side? All right, so I'm going to look at where does missed shots and right side overlap. It overlaps right here at 11. So 11 shots were missed and on the right side team. So 11 out of 33 shots. Okay, so now we're going to look at what's called conditional probability. All right, so this question says, given that a shot was made, what's the probability the shooter was on the left side? Okay, so in probability notation, that says probability, given the shot was made, what's the probability it's on the left side? So this little bar that you see right there, that means given that. So given that the shot was made, what's the probability it came from the left side? So looking at our table, so given that the shot was made, so that means we're only looking at made shots. We're going to ignore everything else, only made shots. So given that the shot was made, what's the probability it came from the left side? So we had 6 left sides out of 13 total made shots. So this probability is 6 out of 13. So notice here that our denominator has changed. We're not looking at the total 33 anymore. we are only interested in looking at made shots. So this happens when you have conditional probability. Your denominator is probably going to change. All right, let's try another one. Given that a shot was missed, what's the probability the shooter was on the left? All right, I'm going to write this in probability notation. So what's the probability the shooter was on the left given, remember that bar means given that it was a missed shot. All right, so I'm going to look at my table. So given that it was missed. So I'm only looking at missed shots. So right away, it's going to tell me my denominator is going to be 20 because I'm only interested in missed shots. So given that it was missed, probability it was on the left. So that's 9. So 9 out of 20. All right, so this would be a good chance for you guys to try G on your own, and then we'll check it together in a second. All right, so G said, given someone from the right was a person shooting, what's the probability it was made? So we want probability it was made given that it was from the right team. All right, so in my table, I circled, okay, I'm only interested in the right team. And what's the probability it was made on the right team? So I'm looking at 7 out of 18 total shots. So whenever you see given that, this is conditional probability. And we can do conditional probability just like we've been doing with a table. But sometimes we don't have a table to use, and so we're going to use a formula instead. And the formula I'm going to give to you guys would have worked for the problems that we've already done. So I'll show you how we could do one of the problems that we just did using the formula instead. So first, here's the formula. So conditional probability is the probability event A will happen under the condition event B has already occurred. All right, so the probability event A happens given B has already happened is equal to the probability of A and B all over the probability of just B. So notice that we're dividing by whatever the given part was. So for example, let's look at G again, that given right probability was made. So this would be the probability of made and right. That upside down kind of U shape means and. So probability of made and right divided by the probability of just the right. Okay, so probability that was made and on the right team. So made and on the right team would be 7 out of 33. So 7 out of 33 divided by the probability that a shot was taken by the right team. So how many total shots were taken by the right team? 18 out of 33. So divided by 18 out of 33. And that simplifies to 7 out of 18. So essentially, we've been doing the formula the whole time. It was just easier to use the table instead of the formula. But let's look at some problems where we don't have a table and we're going to have to use the formula. Actually, let's do H first, using the table method. So using the formula, find the probability the shooter is from the left, given the shot was missed. So probability of left given the shot was missed. Okay, so this is equal to the probability of left and missed divided by the probability it was missed. All right, so for left and missed, how many total shots came from the left team that were also missed? Well, that would be 9. 9 out of 33 total shots were left and missed. So 9 out of 33 is our numerator. So divide by the probability a shot was missed. So the probability that any given shot was missed was, well, let's see, we had 20 total missed shots out of 33 total shots. So 20 out of 33 is the probability that any given shot was missed. All right, so this would simplify to 9 out of 20. Okay, let's see, I was getting ahead of myself a little bit. We're going to look at Venn diagrams, and then we'll look at how we can do conditional probability with like straight up word problems. Okay, so we're going to keep doing conditional probability, but instead of a table, we'll do Venn diagrams, and then we'll look at word problems last. Okay, so part 2. This is a Venn diagram. So we filled in some data in class with who likes just ice cream, who likes just popsicles, and who likes both. So I'll give you some data that we had. So there were 2 people that liked both ice cream and popsicles. There were 3 people that just liked ice cream. There were 7 people that just liked popsicles. And there were 4 people that didn't like ice cream and didn't like popsicles. So that 4 is going to go down here. So total, we had 16 people. All right, so part A says determine the probability someone likes ice cream. So for all these little Venn diagrams down here, I'm going to shade in first where that probability is located, and then I'll write it down. So the probability someone likes ice cream is the entire ice cream circle. So that means if they like both ice cream and popsicles, they still fit in liking ice cream. So how many total people were in the ice cream circle? 5 total people. So 5 out of 16 is the probability someone likes ice cream. Part B, determine the probability someone likes both ice cream and popsicles. So both ice cream and popsicles is only this spot here, right in the middle. So back in our Venn diagram, how many people liked ice cream and popsicles? 2. So 2 out of 16, or 1/8. We'll go ahead and simplify that fraction. So 1/8. All right, this one's a little trickier. Determine the probability someone doesn't like ice cream. Okay, so take a second and think about where you might shade in your Venn diagram. Probability someone doesn't like ice cream. So that's going to be everywhere but the ice cream circle. So, doesn't like ice cream. So I'm going to shade everything but the ice cream circle. So, to figure out this probability, how many people were in the ice cream circle totally? Well, there were 5 people just in the ice cream circle, which means that there's 11 people not in the ice cream circle. That's coming from the 7 that just like popsicles and the 4 that don't like either. So we had 11 out of 16 people. That's a probability someone doesn't like ice cream. All right, part D. Determine the probability that someone doesn't like ice cream and likes popsicles. Okay, so we got an and here. This one's a little bit trickier too. So doesn't like ice cream, that's going to be like we had before, doesn't like ice cream and likes popsicles. So imagine, where does this problem overlap with liking popsicles? Well, that would be just the part of the popsicle circle, not the overlap. So not the whole popsicle circle, but just the part that's only popsicles, not popsicles and ice cream. So these are the people that like popsicles and also don't like ice cream. So in that part of our circle, we had 7 out of 16 people. All right, so now we're going to look at some conditional probability. So determine the probability someone likes ice cream given they like popsicles. So probability, they like ice cream given they like popsicle. Well, that's equal to the probability of ice cream and popsicle divided by the probability of popsicle. All right, so what's the probability someone liked ice cream and popsicle? Well, that's actually what we figured out in part B, because part B said to determine the probability someone likes both ice cream and popsicle, and we said that was 1/8. And what's the probability someone just likes popsicles? Well, there are 9 total people in the whole popsicle circle out of 16 total people. So divided by 9/16. And this will simplify to 2/9. We could have done this also just by looking at our Venn diagram here, because given they like popsicles, so only looking at the popsicle circle, how many of those people also like ice cream? 2. So 2 out of 9 total people in the popsicle circle. So formula or Venn diagram gets you the same thing. Okay, go ahead and try the last one on your own. You can pause the video and then unpause it when you're ready to check. Okay, so probability someone likes popsicles given that they like ice cream. So this is equal to the probability of ice cream and popsicle divided by the probability of ice cream. So again, we already figured out the probability of liking popsicles and ice cream. That was the 1/8. And we also, in part A, figured out the probability of someone liking ice cream. That was 5/16. And this will all simplify to 2/5. Okay, last bit. We're just going to look at some word problems where we have got to use that formula. Also, here's your friendly reminder, all probabilities are between 0 and 1. If you get a negative probability or if you get a probability bigger than 1, you've done something wrong. So, when you're checking your answers, check for reasonableness. Your probabilities have got to be between 0 and 1. So, here we go. A jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34. And the probability of selecting a black marble on the first draw is 0.47. What is the probability of selecting a white marble on the second draw given the first marble was black. Okay, that's kind of a lot. So my strategy is always to kind of write down a probability notation what I have and what I'm looking for. So what I'm looking for is, what's the probability I get a white marble given I already had a black one? So what will I need to figure that out? Well, I'm going to need the probability of a black and white marble divided by the probability of a black marble. So writing it out this way helps me see, okay, do I have probability of black and white? And do I have probability of black? Because those are the two things that I need to figure out what I'm looking for. All right, so let's reread our problem and see what else we've got. The probability of selecting a black marble and then a white marble is 0.34. Okay, that's the probability of black and white. So probability of black and white is 0.34. And the probability of selecting a black marble on the first draw is 0.47. So probability of just black is 0.47. Hey, that's what I needed. So now I'm just going to plug those probabilities into my formula. So here we go. 0.34 divided by 0.47. And that gives me, I'm just going to leave this as a decimal, 0.723. All right, let's try another one. The probability that Janice uses a tanning bed is 3 out of 10. The probability she uses a tanning bed and develops skin cancer is 4 out of 15. Find the probability she develops skin cancer given she uses a tanning bed. So again, probability of developing cancer given she uses the tanning bed. Well, this is equal to the probability of developing cancer and tanning divided by the probability that she tans. And the probability she uses a tanning bed is 3 out of 10, so that's our denominator. The probability she uses a tanning bed and develops skin cancer is 4 out of 15, so that's our numerator. So this simplifies to 8/9. Okay, go ahead and pause the video and try part C. Unpause it when you're ready to check it. All right, so the probability Sue will go to Mexico in the winter and to France in the summer is 0.4. The probability she'll go to Mexico in the winter is 0.6. Find the probability she will go to France this summer given she just returned from her winter vacation in Mexico. Okay, so I want probability she's going to France given she went to Mexico. So that's equal to the probability of France and Mexico divided by the probability of Mexico. So do I have those things? Let's see. The probability she'll go to Mexico and to France is 0.4. Sure enough, that's my numerator. The probability she'll go to Mexico is 0.6. That's my denominator. So 0.4 divided by 0.6 is 2/3.